I'm Anil Kumar. Welcome to my series on IGCSE test papers solutions. This paper here is a specimen paper for examinations from 2020. Mathematics paper 4 0580. I noticed that there is a kind of change in the trend. So what are we learning while solving this test paper through my videos is 1. How to manage your time and effectively solve these questions. Understand concepts behind them and also look into practice questions which are similar so that you could actually solve any question similar to the set you see here in this particular video. I hope that makes sense, right? So instead of jumping into just starting with the solutions, we are going to first try to analyze how to work or how to manage our time. Since there are 2 hours and 30 minutes, that means we have 2 hours means 120, right? So 120 plus 30, we have got 150 minutes, right, to solve this test paper. There are about 11 questions. So first question is, how much time should you be taking for each? If you take 10 minutes for each question, you do it in 110 minutes and save about 40 minutes for revision and looking back into your solutions, right? So we will allocate around 10 minutes for each question. Now this is extremely important. You have to manage your time. So just give 10 minutes for each question. Once your time is up, just move on to the next question. Perfect. That should help you to complete the paper and maximize your potential. So I hope that is a good hint, right? That is how I used to do. Now, secondly, you know that there are 10 minutes to solve each question, so you should not be in a rush. If you are in a rush, you can do calculation mistakes. Perfect. So don't do that. So just take your time and effectively solve the test question. Try to complete it within 10 minutes. Sometimes you could always take extra 10% of your time. Perfect. Even then, you will be with 30 minutes to save and revise. Now let me thank Cambridge people to share their model papers with us so that we could provide you with some guidance. I have also copied these questions in a different format so that we could effectively look into the questions and then solve them, right? So question number 1, let's now begin, right? Question number 1A, Christian and Stephanie share some money in a ratio of 3:2. Christian receives $72. How much Stephanie receives? Now it's a ratio question. You know Christian K, we'll just put K for him, and Stephanie S. Christian gets $72. Okay, $72. To find what Stephanie gets, you need to just work out the ratio, right? So what is the ratio? Ratio is 72 divided by 3, right? 72 divided by 3 will give you the scale factor, right? So in ratio questions, you have to find the scale factor. So what we found here was scale factor. So you have to multiply by 24. So 3 times 24 gives you 72. Does it make sense to you, right? So similarly, you should now multiply 2 by 24. So times 2 gives us 48, and that is our answer for this particular question, right? In dollars. Does it make sense to you, right? So whenever you have a ratio question, follow scale factor. Part B. Christian spends 45% of his $72 on computers. So 45% means 0.45, 45 over 100. Of means multiplication. So you get 0.45 times 72. Right. So 0.45 times 72 is equal to, in decimals, 32.40. So write currency in 2 decimal places, right? So Christian spent so much on computer. Calculate the price of computer. Well, the price of computer is 32.40. So we get our answer there, 32.0. Christian also buys a meal for $8.40. Okay, that's fine. So $8.40. Calculate the fraction of the $72 Christian has left after buying the computer game and the meal. So that means you have to add these quantities, correct? And then left will be from 72, right? So let's add them first. So we get 4 plus 8 plus 2 is 0, 40. $40.80 is the total amount spent, right? So that is what has been already spent. Now carefully read the question. It says calculate the fraction of the $72 Christian has left after buying the computer game and meal. So what is left? That means 72 minus 40, correct? So we should do 72 minus 40.80 to get what is left, right? So that is 72 minus 40, 72 minus 40.80, and that is the left amount, which in decimals is 31.20, right? Still, we are not close to the answer, right? It says calculate the fraction. So you have to read very carefully. Calculate the fraction of $72 that has been left. So what fraction is left? The fraction left will be this amount divided by 72, right? So that is the fraction, correct? Over 72. So that is the fraction we are looking for. So let's divide this by 72 to get our answer, which is 13 over 30. So that fraction is left. So this becomes our next answer. Perfect. Now 4 is Stephanie buys a book in a sale for $19.20. The sale price is after a reduction of 20%. So this is the lower price. Calculate the original price. So we want higher price, right? So original price. Does it make sense to you? Now, Stephanie actually paid 20% less. 20% less means she paid 80%, right? So paid 80%. So that is how you could see, right? So that means 80% means 0.80 times the original amount, which is X, should be equal to 19.20, right? So X will be equal to 19.20 divided by 0.8. So you'll get a higher amount. Perfect. Does it make sense to you? So we'll do 19.20 divided by 0.8, which is $24. So the original price is $24, correct? So we get all our answers. So the answer for this is $24. The first one, we found that Christian receives $48. Stephanie receives $48, right? Second one, after spending, calculate the price of computer game. The computer game was $32.40, right? And here the fraction was 13 over 30. Is that clear to you? So that is how we have answered question 1A, right? We still have part B left with us. So let's move on and take question 1B now. Question 1B. Boris invests $550 at a rate of 2% per year simple interest. Calculate investment at the end of 10 years. So the money is going to grow, right? And it is a question based on simple interest. So P equals to, so interest is PRT, right? So in this case, we can find the interest, which is PRT. So that is the amount by which the money is going to grow, and we'll add this to the original amount, right? So interest earned in this particular case is principal of 550, rate is 2%, that is 2 over 100, right? And the time is 10 years. And the time is 10 years. So that is the interest earned. So we'll do 550 times 2 divide by 10, right? So we can do this, 110. So that is the amount which increases, correct? So, but we need to calculate the investment at the end of 2 years. So the amount will be principal plus the interest, which in this case will be 550 plus 110, which is $660. Is that clear to you, right? Now, as far as the calculations are concerned, some of you could actually calculate so easily. Do you see that? So you could do this, and without calculator at times you could do, right? Question 1C. Merrily invests 550 at the rate of 1.9% per year compound. So this is yearly compound, correct? Interest. Calculate the value after the end of 10 years. The amount after the end of 10 years will be principal amount plus 1 plus there is interest on interest. So the formula is 1 plus r to the power of time t, right? In our case, we are given p as 550, 1 plus rate of interest. You could write 1.9 over 100 as we did earlier, or you could write 0.019, right? So take care. Sometimes you may write 0.19, which will be wrong, right? So over 10 exponent, right? That is what you need to calculate. So to calculate, we'll start from inside. So we have 1.019 to the power of 10, right? And then we are going to multiply this by 550 to get our answer, which is $663.90, correct? So that becomes your answer. Is that clear? Hans invests $550 at a rate of X% per year compounded interest. At the end of 10 years, the value of the investment is 638.30. Find the value of X. So now we need to calculate the rate of interest. We are given the amount. So we'll use the same formula, the amount being 638.30, correct? Principal is 550 plus we don't know the rate, right? So rate percent is not known to us. We need to figure this out. And we know for after 10 years, that is the amount. Perfect. So how do you solve such an equation? First step should be, you have to divide this by 550, right? So we get 638.30 divided by 550. So that is equal to 1 plus r% to the power of 10. Now we have to do 10th root of this, right? So let's take it on this side. So that means 1 plus r% is equals to the 10th root, or to the power of 1 over 10 of 638.30 over 550, correct? So let's figure this out. So it is 638.30 divided by 550, and that is equal to that number. We'll do to the power of 1 divided by 10th, so 10th root, which is equal to 1.0150. So we know that 1 plus r% is 1.0150. So r% is equal to 1.015 minus 1, which is equal to 0.015. To find the rate of interest, we'll multiply this by 100, right? So that multiplied by 100 gives you 1 point, so decimal moves 2 places, correct? 1.5%. Does make sense to you, right? Or in the formula, you could have written r over 100, right? You could have written this formula as A is equals to P, 1 plus the rate is X in this value, right? So we'll write X over 100 to the power of T, right? You could use this formula, so it gets multiplied. You get the idea? So the answer for this is X is equals to 1.5%. Does make sense to you? So that is how we are going to solve this particular question. Now fill in all the answers correctly. One is $660. The other one is $663.90. So I hope you get it right. Now let's move on to question which is related to a cumulative frequency graph. So the question is right here. There are 200 students who estimate the volume of a classroom The cumulative frequency diagram shows the result. So that is the result which we will work with. So the graph is given to you. Now in this particular graph, you can see the cumulative frequency for the estimate of the volume. Now we need to analyze this graph and answer a couple of questions. The questions are rewritten like this. So the question really is, 200 students estimate the volume V meter cube of a classroom. The cumulative frequency diagram shows their results. Use graph to find an estimate of median, the interquartile range, the 60th percentile, the number of students who estimate that the volume is greater than 300 meter cube. How do you find these answers? So basically, if you analyze the graph, the S curve which you see for the cumulative frequency, you have to read all the values very accurately from this curve, right? So cumulative frequency gives you the student number, and here on the horizontal axis you have the volume. So for example, the median is the center value. Since there are 200 students, we have to read what corresponds to the 100th value, right? So that is how we have to read and answer the questions, right? So let us see how to read the median from the graph first. So since there are 200 students, so we'll actually do 200 divided by 2, which is 50% of this, so 100 student, right? So for 100 student, the volume estimate of the room is this point, right? So you can read it directly here. So when you go down on the horizontal x-axis, the volume indicates 400. So that becomes the median, which you can also say the second quartile, right? So we can write the value 400 for the median. Perfect. So in this, the median is 400 for us, meter cube. Do you get the idea, right? So that is how you get your answers. Now, when you talk about interquartile range, it means what? It means we need to find what is Q3, and from that we have to take away Q1, correct? Now, Q3 is 75%, right? So Q3 is 75%, and Q1 is 25%. Now, so what is 75% of 200? That is what we have to read, right? So that means we are looking into 200 times 0.75, which is 150, right? And as far as Q1 is concerned, 25% or quarter of 200, right? So 200 times 0.25 is quarter of 200. So half is 100, quarter is 50. So we are looking for the values corresponding to 150 and 50, right? So is that clear to you, right? The difference between these two values will give us the interquartile range. So let's get back to our graph, right? So again, here's the graph. So we are looking for values for 50 and 150, right? So let's start with 150. So 150 is between 140 and 160, just the center value. So each division here is 4. So 4, 8 and 10 will be in between, right? So that is 150, correct? So that gives you the value for Q3. So it strikes here, so which is, let's go down this path. You need to use a scale to get accurate results, but I think you can read it from the graph fairly well. So it is 420. So that is the value for Q3, which is 420, right? So that gives you 420 as the value for Q3. So we're trying to find Q3 here, right? Which gives you the value of 420. Okay. Now let's see what is Q1, which is 50 for us. Now 50 is between 40 and 60, so right there. So this value, right? So let's read this. It is 350. So what we get here is Q1 equals to 350. So interquartile range is difference between these two. 420 minus 350, correct? So let's get back to the paper, and we got these values as 420. So we have 420 minus 350, correct? So that gives you 12 take away 5 is 70. So IQR, the interquartile range, is 70. Is that clear to you? Perfect. That is how you're going to answer. Now, how about 60th percentile? 60th percentile means 60 over 100 or 0.6 times 200. That is the number of students, right? So 0.6 times 2. So 6 times 2 is 12. So it is 120. So we'll now again get back to the cumulative frequency graph and read the value corresponding to 120 this time. Okay. So let's figure this out. So for 120, okay, here it is. We can go straight. That is the point, right? In between. So this actually is slightly less than 410, right? So it is slightly less than 410. Okay. Right, so not exactly 410, okay, but slightly less than that, but you know what, 410 we could give as our answer, right? So let's give this value as 410. So 60th percentile, you can write 408 also. So for 60th percentile, we read the value as 408 approximately, right? So it looks like 408 actually. But, well, because the graph, there could be errors. So 410 could be an acceptable value. Perfect. Okay. Now let's look into part 4, which is the number of students who estimate that the volume is greater than 300 meter cube. So let's see how many estimate at 300, right? From there, we'll get greater than 300, right? So this time, we have to go from the horizontal x-axis. So we'll go upwards from 300 and there you go, right? So this is the value. So this is in between, there you go. So it seems to be 30, right? So that is the value which you get. So we want greater than 300. So greater than 300 means 30 or below or less than. Do you understand? So when you say greater than, that means 200 is all. So we have 200 minus 30. So we get 170 students who are estimating the volume to be greater than 300. Is that clear, right? So we can write down this answer, which is there are a total of 200 students and minus 30 of them will give us 170 students. So that is the answer for the estimate value for number of students who estimate that the volume is greater than 300, right? So these are the answers which we have got. So the first answer for the median is 400 meter cube. For interquartile range, it is 70, right? And for the number of students which estimate greater than 300 meter cube is 170, right? Does it make sense? Question number 2b. The 200 students also estimate the total area, a meter square, of the windows in the class. The table shows their results. So we are given these areas estimated by the number of students is shown here. Part 1 is calculate an estimate of the mean. Now this is a group data, correct? So we kind of work like a weighted mean, right? So what we find here is the center value, so the middle value, the average of the group. So we'll assume that all this frequency relates to the average. How do we find the average? We'll add these two, divide by 2. 60 plus 20 is 80, divided by 2 is 40. So we get average of 40. Now here, we have 160, so we are going to divide 160 by 2 to get 80. In this case, 250 has to be divided by 2, adding 100 to 150, and we get 125. The third case here is 150 plus 250, which is 400. When you divide, you get 200, correct? Now what you should note here is that the interval is not same. 20 to 40, 60 to 100 is the interval of 40. Here it becomes 50. Do you see that? So there is a difference in interval. So just don't add by 40 more and quickly do your questions. You have to be very careful in this test paper. So I do find that there are some places where if you overlook, you will unnecessarily make an error. So don't rush, okay? Now, to find the mean, what should you do? You should find the product of the frequency and xi, right? So let's find their product. So multiply these two quantities and write your result here. Let's use a calculator, right? So we have 40 times 32, which is equal to 1280. Then we have 80 times 64, which is 5120. 125 times 80, which is 10,000. And then we have 200 times 24, so 4,800. Correct? So what is the mean? Mean here is sum of all this, which is XIFR divided by the number, total number, which is, you can say, sigma of F, right? Total number of students, correct? Which is 200 for you. Perfect. So we'll just add them up. So which is 1280 plus 5120 plus 10,000 at 4,800. So what do you get? You get 21,200. Divide this by 200. You get your answer as 106. So 106 becomes your mean. So that is how you're going to answer this particular question, right? So I hope that is absolutely correct. And the units will be meters square. Complete. Now let us try to understand how do we get the frequency density, right? So the important thing here is to understand frequency density, right? So let me write down the term frequency density. So you could get frequency density by finding the interval. So in this particular case, what is the interval? The interval is 250 minus 150, which is 100. Now within this interval of 100, we have to show 24, right? So the density will be the frequency divided by this particular interval. So let's call this delta. Is that okay? So that is how we are going to calculate the frequency density, correct? So let us find frequency density for each. So before that, let me just calculate the intervals for each. So for this one, the interval will be 150 minus 100, which is 50. Here the interval is 40, and 40 is also the interval in the first case, correct? So the ratio of dividing 24 by 100 will be 0.24, right? So basically just divide 24 by 100. So we get this ratio as, let's write it in a different ink so that there is no confusion, right? So this ratio here is 0.24. So what are we doing? We are actually dividing 80 by 50, correct? So we are dividing 80 by 50 to get our number, correct? So that is how we are going to calculate. And in this case, it will be 64 divided by 40. Here it will be 32 divided by 40 to get the density, right? So let's calculate. So we'll do 32 divided by 40 gives us 4.5, 4 over 5, which in decimals is 0.8. So this is 0.8. The second one is 64 divided by 40, which is in decimals 1.6. The third one here is 80 divided by 50, which is equal to, in decimals, 1.6. The last one, of course, is 24 divided by 100, which is in decimals 0.24, correct? So these are the values which we have to match, correct? So let me write down these values in our histogram. So 0.8, 1.6, 1.6 and 0.24. So we're just writing the numbers here, and then we'll actually find the height, right? So what we have here is different intervals from 20 onwards, correct? So the values are, so let's first write down the intervals. We have an interval 150 to 250 already given, 100 to 150. So that is one interval. And in this interval, we calculated density as 1.6. We have to show 1.6 here, right? So somehow 1.6. I'm writing here. We'll write later there. The other interval is from 60 to 100. So which is this group, right? 60 to 100, that group. Within 60 to 100 also it is 1.6. And then it is 20 to 60, right? So this is the third interval in which we got the frequency density as 0.8, right? So 0.8. So let's read 0.8 from the graph. So 0.8 will mean from here, right? That is 0.8. So we get this bar 0.8 for the first interval, which is between 20 to 60, right? Next one, 1.6. So this is 1, 2, 4, and 6. So that is 1.6 for us. And 1.6 is also for the next interval. So, well, let's draw the bar here, okay, and complete our diagram. So that is how we are going to do it. Now, each here represents the numbers, right? So if you multiply this length with the height, you get your numbers, which is the frequency. Do you understand? So in the first case, the frequency will be 32, here it will be 64, 80, and 24 in this particular case. The height of these bars, the histograms, is, here it is 0.8, and here it is 1.6, correct? So that is how you're going to complete it. So I hope that is absolutely clear, right? So let's move on and do the next question, right? So we have done this on the graph paper. The next question here is, two students are chosen at random from those students that estimated the area of the windows to be more than 100. So when we say more than 100, that means we are talking about this group, right? So we are talking about this group, which is more than 100. Okay. Find the probability that one of the two students estimates the area to be greater than 150 meters square and the other estimates the area to be 150 meters square or lesser. So that means we want to find the probability that one of the students is from this group and the other student is from the other group, correct? So that is the question for you. Now, how to solve this question? Let's look into total number of students in this group. That comes in the denominator, right? So the total number in this group is 80 plus 24. So we write total T is equal to 80 plus 24, right? Which is 404 students in all. Now, when you are selecting, you could select the first student from this group, second from the other group, or it could be the other way, right? First student from this group and second student from the other group. You get an idea. So it could be either way, right? Now these events are not independent. They are dependent. Since one student selected is not replaced, you get an idea, right? So the denominator changes to 103 when you select the second student. Perfect. Now, selecting a student from group 1, let's call this as group 1 and this as group 2 first, right? So case 1 will be selecting from group 1 first. So we have 80 students here. So out of 80, let's write 80 over total is 104. Now the second one is selected from the other group. Probability will be 24 divided by 103 since one has been already selected. So we are left with 103. So that is the first case, right? The second case will be you select first from here. So if you select first from here, it will be 24 over 104 times second from this person, this group, right? Which is 80 over 103. So that becomes the probability. Perfect. So remember, it is an event which is dependent, right? So because selection reduces the group set by one number. So that is, these two numbers effectively are same. We could just multiply by 2 after calculating. So I'll do 80 times 24, right, divided by 104 times 103, right? And then we are going to multiply this by 2 to get our answer, since it could be either way, right? We get 480 by 1339. So the answer is, probability in this case is 480 divided by 1339. So that becomes the probability. So sometimes you may write it in percent. It is 35.8%, correct? So that is the answer. Or you could write 35.8%. Does it make sense to you? So that is how you're going to answer this question. I hope the concept is absolutely clear. Now let's take question number 3. We are given a function f of x, 20 over x plus x, where x is not equal to 0. We need to complete the table. Some values are given. And part B of this question is, on the grid, draw the graph of the function in the given interval from -10 to -1.6 and from 1.6 to 10. So we need to graph it here. So what I've done here is that I've copied the question for your convenience. So let's try to understand the question itself. One important thing which I want to highlight here is, while solving such test papers, we have to keep in mind how to save our time, since time is very critical in completing the solution of the whole test paper. Correct? Now let's look into this question. Question number 3a is to complete the table for the given function, and 3b is on the graph, on the grid, draw the graph of this particular function. C is, using the graph, solve the equation f of x equals to 11. So we have to read the graph also. That means very accurate drawing is required. Perfect. We'll see the other parts later. Now, to calculate the values, very simple. We have to just fill in these two values. You can plug in 5 and calculate, which is 20 divided by 5 plus 5, and that is equal to 9, right? So we found this value to be 9. You could also do one more thing. You look into the symmetry. Do you see that? So here 0 value is not valid, and you see how these values are related, right? On this side we have all the positive values, all negative values. However, their numbers are same, right? So what do you expect here? You expect minus 10.4, 5 times minus, that is 10.5. Is it okay? 12 and 12 already matches. So straight away we see some trend. Does that click something? It really means that this function, if I do negative of this function, what do I get? I get 20 over minus x, which is negative of the function itself. So this is an odd function, right? So when you say an odd function, you know it is symmetric about origin. Now that helps to sketch. And that is why I'm taking a minute here to explain the concept. If you catch on this, then half of the graph can be just raised. Make it symmetric about the origin, and you're going to save lot and lot of time. Doesn't make sense, correct? Okay. So we'll sketch the graph later exactly. Let's first try to understand. When you have this kind of a function, we do have a vertical asymptote at x equals to 0, and this x tells you what? If x is very large number, you are approaching this line. That means we have an asymptote here, right? So we have an oblique asymptote in this particular case. So if you sketch this particular graph, what do you expect? We expect that the graph is going to approach this diagonal line as it goes towards the infinity, right? So that is kind of important. And second important part is that x is not equal to 0. So we do have a vertical asymptote. Perfect. That is important. You have also noticed here that the values are actually somewhere in between missing, right? So if you look into the positive half of it, the values minimum is 9 and then it increases, correct? So as you approach closer, it increases. So the graph could be kind of like this. Do you see that? And similarly, on this side, we expect a graph like this. So that is the graph which we are expecting. So when you sketch this graph, keep this in mind. Perfect. Right. Now, question 3D is k is a prime number. F of x equals to k. Has no solution. Find the possible values of k. No solution will be somewhere in between. Do you see that? So you don't see any value which is between plus and minus 9. So all the prime numbers between this could be part of solution. Does make sense to you? Correct? So we could answer this question immediately. The prime numbers are 2, right? 3 and 5, and you could go to 7 also. Perfect. So 7 is also a prime number. These are the prime numbers which you could list for 3D. What I'm trying to tell you here is that you have a fairly good idea of how to sketch it, right? And then you can answer questions immediately. Using graph, but using calculator, you can estimate this value also. F of x is equal to 11. That means we know this is 9, right? So we'll try to sketch this line. Definitely, there are two values. Do you see that? So two values, which should give you 11. And since the graph is asymptotic to y equals to x, one of the values is very close to 11. Perfect. So we get an estimate of our answer. Does make sense to you? Now, let us actually solve the equation. So all this I told you so that if you get a similar question, you should be in a position to save some time. Perfect. That is the whole idea. Now, since we have seen that the graph is symmetric about these two axes, we'll focus more on the first quadrant, right? And you can trace that over to the second quadrant. Does make sense to you, right? So let's get back to the values. So here is the original printout, and we'll actually fill in the value which we just found. So it is symmetric. So we said this should be at 5, it should be 9, and that should be 10.5, correct? And now we have to place these values. We have also found that this is a graph which has to be symmetric or symmetry, right? So we are focusing on the quadrant 1, right? So let's use a lighter coloring so that we can mark all the points, right? So 5 and 9 is a good value to begin with. So 5 is just in between these two, 4 and 6. And we have a value which is 9, which is kind of here, right? So we have a value which is 5 and 9, and that is our minimum, right? Now, 2 and 12, so as I move here, on 2 side, I get 12, and then 1.6, 14.1, so 1.6 means between 1 and 2, and we have 14.1, so somewhere here, right? So that is how we could get this point. 8, 10.5. So at 8, we have 10, and this is 11. 10.5 will be somewhere here. And at 10, we have 12. So at 10, we have 12. So that is next value. Joining these, we have our graph, right? Since we have to sketch only between 1.6 and 10. So let me join these with a curve, which we just talked about, correct? So that becomes, now this is asymptotic, right? So so that's how you should be sketching it. Now on the other hand, you know it is symmetric. I'm not sketching it now, but you could copy these values and sketch on this side also, right? Does it make sense? Okay, so what I've done for you is this part. Now, from here, let's look into the other parts and try to get the answer. We wanted to know what are the prime numbers for which, now as you can see, there's nothing in between, right? So it seems that the range is above 9, right? So this is 9 for you, correct? So it is above 9. So the prime numbers less than this will be 2 and will of course be 5, right? There's nothing which can, and of course is 7. Do you see that part, correct? So we have answered those questions also. It makes sense. There's no part of the graph within this interval. So no solution. Okay, now using the graph, solve the equation f of x equals to 11. Now we have to solve for f of x equals to 11. So let me sketch a line at 11 and see where it intersects, correct? So 11 is somewhere between 10 to 12 and that is our line, correct? So one of the solutions is right here. The other one which intersects here is, it could be taken as a point slightly more than 8, right? It's on the right side. So these are the 2 points, right? So that is what we get. And you can read this solution from your graph approximately, right? You cannot be very accurate in this, but you have to estimate from the graph. So the idea here is that it is less than 3, right? It is on this side of the line. So you could say 2.8, for example, correct? So that could be 2.8, for example. And here it is slightly more than 8, right? So each division here is, now that becomes 9. So you could say it is 8.3. So my estimate will be 8.3 and 2.8, right? That is what I could estimate. Perfect. So that gives you an idea that 11 is going to be somewhere here, correct? Perfect. And somewhere there, right? Between these 2 points. So that is the estimate for us, right? Not a bad estimate. So we get a value of 2.8 and 8.3. Of course, you can use your calculator and check your value, how good it is or not. Perfect. Okay, let's move on and answer the next question now. Okay, so we have an estimate. The values for us are 2.8 and 8.3. Correct. 3e. The gradient of the graph y equals to f of x at the point 212 is -4. Write down the coordinates of the other point on the graph of this where the gradient is -4. What should be the other point? Now from the symmetry, you could easily say what the other point should be, right? Since the two graphs are symmetric. Does it make sense to you, right? So that is how understanding symmetry helps, correct? So we will say the other point is -212. So we get this point as the other, right? So you have already given 212 as a point. Since the graph is symmetric, you can see whatever the gradient is here, same we will expect at the other place also. So immediately, without even doing any work, you can say it is -212. The answer is odd symmetry. Perfect. So that is an excellent explanation. Perfect. So I hope the solutions are absolutely clear. So we got the symmetry, and from there we got our answer. The next point should be -2, -12. So it should be actually -12, right? So the answer is -2, -12. Correct? Now let's take up the next question, which is 3f. The equation of f of x equals to x squared can be written as x cubed plus px plus q equals to 0. Show that p equals to -1 and q equals to -20. Now, what are we given? We are actually given the equation of f of x as equal to 20 over x plus x, correct? Now, when we are saying that if f of x is equal to x squared can be written as this, right? Then the value of p should be -1 and q should be -20. So we'll replace f of x with x squared and solve this particular thing, right? So we have x squared here, which is equals to 20 over x plus x. If you multiply by x, you get x cubed equals to 20 plus x square, which you can rearrange, and when you rearrange you get x cubed minus x square, and then 20 comes on this side, so minus 20 equals to 0. Now if you compare these two equations, what do you find? You find that the value of p is minus 1, so we get p as equals to minus 1, and that is q. Q is equal to minus 20. Doesn't make sense to you, right? So comparison helps you to prove. So we have x cubed plus px plus q equals to 0. So that gives you these values. Perfect. Part 2 is draw the graph of y equals to x squared for minus 4 between x between minus 4 and plus 4. So that is a parabola, right? So we'll get back to our graph which we just sketched, and then on the same graph we can draw the parabola. So okay, so let's write down the values so that now we'll draw y equals to x squared, and we are taking the values from minus 4 to plus 4. That means 16 plus and minus, right? Okay, so here we have our graph paper, and we have to sketch the function x squared on this graph from minus 4 to plus 4. So minus 4 will give us 16, right? And plus 4 will give us plus 16. And 0 will give us 0, right? So that is the position. So that is the position of the graph, and these points plus and minus 4 are included, right? Plus and minus 4 are included. So these are your points. Second, when you draw the graph, you can go by steps, right? So 1 square is 1. So we have, in this point, we have 1 here and 1 here. And 2 square will be 4. So at 2 we have 4 here, right? And 3 square is 9. So 3 square is 9, somewhere there, right, in between these two. Okay, so we are getting a graph kind of like this. So let me sketch this parabola, right? So we have this graph here, which is, and this graph is symmetric about y-axis. This is an even function, right? So that is your graph between these two positions, between minus 4 and plus 4. Does make sense, right? So that is how we are going to sketch this particular graph. Now the question is, using your graph, solve this equation x cubed minus x squared minus 20 equals to 0, right? Okay, so now we need to solve for x cubed minus x squared minus 20 equals to 0. How do you solve this? Well, how did we get the graph? So this is a point where x squared intersects the original function, which is 20 over x plus x, correct? So from the graph, we'll find that particular point, right? So let's get back to our graph and we'll locate the point where they intersect. So this is the point where they are intersecting. So that becomes the solution, right? So the x value here is, we can say, 2 units less than this, right? So it is 3 point, let's say, so it is slightly more than 3. So we can say 3.2 or something, correct? So we could estimate a value which is 3.2. So I'll estimate this to be 3.2 as the value, right? So the x value is 3.2. Now what does it say? Using your graph, solve this equation. When we solve the equation, we are only finding the x value, right? So we get x equals to 3.2. So that becomes the answer for us. It does make sense to you, right? So we got the answer as 3.2 for this question. Now let's do question 3F4. That's the last point. Graph of y equals to x cubed minus x squared minus 20 equals to 0 has a point P n0. So actually this 0 should not be there. Graph of y equals to x cube minus 2x minus 20 has a point P n0. Find n, right? Now that really means that we are going to find the x-intercept of this graph. The graph is provided to you. Here is the graph for the given function, right? So the question is right here. The diagram shows a sketch of the graph of y equals to x cube minus x squared minus 20. P is a point n0. Write down the value of n, correct? Now what is this value of n? This value of n has to be same which we got earlier, which is x equals to 3.2. So since, how did you get this equation? Y equals to x cube minus x squared minus 20. We got this equation by equating x squared equals to the function. So when you bring x squared to the right side, you get this equation. So we are looking for the x-intercept. So that x-intercept has to be at x equals to 3.2. So we'll write this estimate here as our answer. Perfect. So that is how we are going to solve this particular question. Question number 4 here is, draw the reflection of triangle T in the line x equals to 0. Now, very first statement could create a lot of confusion for students, as some may not understand what is the meaning of line x equals to 0. Line x equals to 0 means the y-axis. Do you understand? This is what we're talking about. So it really means the y-axis. So you have to reflect on the y-axis. Every point on y-axis has x equals to 0. So that's the vertical line we are looking into. So I hope this first thing is very clear. Now it becomes very simple. So this point, that is the triangle for us, triangle T, which we are looking into. The other triangle is triangle U. I forgot to type in their names. Okay. Now, the coordinate points will be reflected so they look same distance away. So at minus 2 will come to the value 2. So what you notice here is for this particular transformation where it is reflection, the x and y coordinates will actually change to minus x and y, correct? So y value remains same. The x value becomes negative of whatever it was, right? So the first one is at minus 2, it becomes 2. The second one is minus 4, it will be 4. And here this vertex, which is at minus 4 again, the y value being minus 2 will now be appearing at 4. So we have a triangle here which has been reflected on the y-axis, which is x equals to 0. So I hope this part is absolutely clear, right? Now part B is, draw the rotation of triangle T about minus 2 minus 1 through 90 degrees clockwise. How do we do that? And what kind of transformation takes place? Now, if you have a point xy in quadrant 1, for example, right? And if you rotate it clockwise by 90 degrees, what will happen? If you rotate it clockwise by 90 degrees, it will appear in quadrant 4 where y value will be negative, right? And the x value and y value will swap. So it will kind of look like this. Do you see that part? So that is how it will look after the reflection. And the new quadrants will be x and y will change. So we get y, and you see the y value is negative, right? So that is the transformation. So that is what happens when you rotate 90 degrees clockwise. Now in our case, we are given a point. However, this point is not the origin. It is minus 2 minus 1. So minus 2 minus 1 is that point. How do I rotate clockwise with this point? I know it will be somewhere there, but how do I exactly get the points? Well, the strategy is make a new coordinate axis. That is the strategy which I wanted to share with the help of this example. Okay, I have many other videos on this topic, so I'd like you to look into those videos also. So now we have a new coordinate axis. Let's call this as the new system, right? New coordinates. So let's write down the new coordinates according to the origin at minus 2 minus 1. So according to this, these points will now be what? So let's call them A dash, B dash, C dash, right? Okay, so in that case, the coordinates for A dash will be, reading for the new one, 0 and 1, 2, 3, 4, minus 4, right? So it is 0 and minus 4. The B value will be, you are moving from here 2 units to the left and then going 4 units, right? So 2 minus and then minus 4, correct? So you moved like this. And for C dash, you actually moved again 2 units to the left and then 1 unit down. So minus 2, minus 1. Now after the rotation, which is 90 degrees clockwise, correct? What happens? These points, so we say A double dash will be, they will swap. So we get minus 4, 0. 0 plus minus is 1 and the same thing. As far as B is concerned, we get minus 4 and this 2 becomes positive, right? For C double dash, the image will be at minus 1 and 2. So those are the new points for us, correct? Let's plot these points now and get our answer. So A dash is minus 4, 0. So that will appear at, we are looking with reference to a new coordinate, right? So from minus 2, it goes to minus 6. That is what minus, it doesn't really move along the y-axis as per the new. So minus 4, 0 is our point. So that is A double dash, correct? B double dash is minus 4, 2. So from here, we'll go 2 units up, correct? And C double dash is minus 1, but this value is 2. So from here, just 1 away right there. So we have our new triangle, which has been rotated clockwise by an angle of 90 degrees. Does it make sense, right? So we'll call this as T double dash, correct? So that is our triangle T, let's say reflection R. Let's call it R, since I use dash here. Okay, so that is our answer, correct? So clockwise rotation is our triangle T double dash, and this reflection is our TR. Question number 4 says, describe fully the single transformation that maps triangle T onto U. So what is that single transformation? So if you look at these two, we have the same size, right? So we have same size. That means it is basically translation. Now what kind of translation is this? So if you compare a point, let's say A dash, so this is the, let's say A3 prime, it has moved 1 unit to the right. So we can say 1 unit to the right, right? So we'll write a matrix kind of a thing. And how much up? So as far as it's concerned, it is moving from minus 5 to 4, 9 units up, right? So 9 units up. So that is how you could describe the transformation, right? So the transformation is 1 unit, right? And 9 units up, which we'll write as a single transformation as a matrix 1, 9. Does it make sense to you? That is how we are going to answer this question. So I hope the concepts are absolutely clear. Have a good look at it and see how we actually we actually have drawn a new coordinate system and then rotated. The origin should be at the point about which you have to make a rotation. I hope that helps, right? Now let's take question number 5. The perimeter of the triangle is 80 centimeters. The area is A, right? So this area is given as A. Perimeter is 80. Now if you look at this rectangle, we are given one side which is X centimeters long. Now based on this, we have 3 questions. First is, show that x square minus 40x plus a equals to 0. How do we prove that? So basically we are relating area, right? Now what we are given here is that perimeter P is 80. Now what should be the perimeter? Perimeter should be length plus this side x times 2, right? That should be the perimeter if L is the length, right? So we can actually simplify this. Dividing 80 by 2, we get 40, correct? that should be the sum of length and the side. So this should be equal to 40. So from here, because we don't have any L here, we can write L in terms of X. So from here, we can say that length equals to 40 minus X. So this length is actually equals to 40 minus X. Now if that is the length, what is the area? So in that case, area should be equal to length times X, right? Which is 40 minus X times X. So that gives you area equals to 40x minus x squared. Now this you could get by bringing all of them together. So if you bring it to the left side, you get x squared minus 40x plus a equals to 0. And that is how we could actually show this. Correct? Now let's look into second part, which is when a equals to 300, solve this equation by factoring. So, okay, so let's do factoring now. We are given a as 300. So let's rewrite this equation with a as 300. So we get x squared minus 40x plus 300 equals to 0. To factor, we need sum and product. 30 times 10 will work for us. So we get x minus 30 times x minus 10, that should be equal to 0. So that gives you x equals to 30 and x equals to 10. So we get two values here. Perfect. The units are in centimeters, so these will also be in centimeters. So when you solve for this, you get x equals to 30 centimeters and 20 centimeters. 10 centimeters, right? So these are the two values. Part 3. When a is 200, solve the equation using quadratic formula. Okay, so let's use the quadratic formula and solve this equation for a equals to 200. So let's rewrite the equation. We have x squared minus 40x plus 200 equals to 0. So then x will be minus of minus 40, which is 40, plus minus square root b squared, which is 1600, minus 4ac, so 4 times 8 is 800, divided by twice a, which is a is 1, right? So we get this. Now within the square root we have 800. 800 is 400 times 2. We could write this as 40 plus minus square root of 800, right? So 800 I could write like 400 times 2. Does it make sense to you? Well, you could use a calculator to find this value. Okay, so what we have here is 400 is 20, right? So 2 times 2 is 4. So we get 40 plus minus 20 square root 2 over 2. Dividing by 2, we get 20 plus minus 10 square root 2 as our answer, right? If you have to provide answer to decimal places, you could use calculator, right? 20 plus 10 times square root 2. And then you can change to a decimal value, which seems to be 34.14, right? For the time being, I'll just leave it as a whole number. So there are two roots. So when a is 200, solve this equation using quadratic formula. So you could write your answer as 20 plus minus 10 square root 2. Perfect. Now let's take the part B of question number 5. Question 5b. A car company completes a 200 kilometer journey at an average speed of x kilometers per hour. The car completes the return journey of 200 kilometers at an average speed of x plus 10 kilometers per hour. Show that the difference between the time taken for each of the two journeys is 2000 divided by x times x plus 10 hours. So basically it is a distance time word problem, right? So we are given a distance which is 200 kilometers. So while going, the speed is x kilometers per hour, and while coming back, it is higher, right? So it takes lesser time per hour, correct? So we need to find the difference between the time taken for each of the two journeys, right? Now, distance, speed, time. Remember the graph, right? So the distance, speed, time, this triangle, right? So distance, speed, and time. Time is basically equal to distance over speed. So we'll find both the times and take the difference. Perfect. Now which time is higher? This time has to be higher since lower speed. So the difference is going to be 200 is the total distance, right? So we can write here 200. Let me use a different ink now. So we have 200, the distance, divided by the speed, which is x, minus lesser time, which is 200, divided by higher speed of x plus 10. Does make difference. Okay, so now we can take the common denominator, which is x times x plus 10, same as here, and we'll cross multiply. So we have 200 times x plus 10 minus 200x, right? You can take 200 common. No need to expand this. You take 200 common and write x plus 10 minus x in the bracket over x times x plus 10. And now x minus x is 0, so you get 200 times 10, right, which is 2000, right? X and x cancel, correct? Let me just cancel this here. So you'll multiply with 10, 200, so you get 2000 divided by x times x plus 10, which is same as this. Perfect. So that is how you're going to show your work. Now part B is find the difference between the time taken for each of the two journeys when x is 80. So basically just substitute 80 here. So we get 2000 divided by 80 times 80 plus 10, right? So that is your answer. So 2000 divided by 80 times 90. So we have 2000 divided by, within brackets, let's write 80 times 90. And that gives you 5/18. Now, you want to give the answer to minutes and seconds. See this. This is very important to understand, right? So you have to now write down in minutes, hours, and minutes and seconds. So let's first convert to decimals. So we get 0.27. Okay. So that is what we get is 0.27. To get minutes and seconds, we actually multiply this by 60, right? So when you multiply by 60, you get 50/3, which is 16.6 recurring, right? So we get 16 minutes and 0.6. So what we are going to do is it gives me 0.27 recurring. So when I multiplied this 0.27 by 60, we get minutes. So we get minutes, which is 16.6 recurring. Now, I have to convert that 0.6 recurring into seconds. So I'll remove that 16 by doing minus 16. You get the idea, right? So I get only 0.6 recurring. I multiply this by 60 to get seconds as 40. So you get 16 minutes and 40 seconds. Doesn't make sense to you. So that is a trick to do with the recurring numbers, right? So we get 16 minutes and 40 seconds as our answer for difference of time. I hope that makes sense, right? Now let's move on to question number 6. Question 6a. OPQR is a rectangle and O is the origin. M is the midpoint of RQ. So these two sides are equal. PT is to TQ. PT is to TQ is 2:1. So that is twice that length, right? So that is 2:1. OP, O to P is a vector P and O to R is a vector R. Find in terms of P and or R in its simplest form these things, which is MQ, MT, and OT, right? So these are the things which we need to find. Now this question is based on vectors. So first thing which we need to find is what is M to Q, right? M to Q. Now it is very clear, M to Q, this is parallel to OP, right? And it is also half of OP. So this is half of P, correct? So that is what it is. Rm is also half, it is given, and since it is a rectangle, these two sides are parallel, correct? These two sides are parallel. So m to q is equal to half of p. Is that clear to you? Now we need to find what is m to t. So let's highlight m to t and then figure this out. So m to t we have to find, correct? Now how can we reach from m t? We are given that this side is in the ratio of 2:1. That means if I divide into 3 equal parts, then this becomes 2/3 and this becomes 1/3. So they are in the ratio of 2:3. 1/3 and 2/3 of what? 1/3 and 2/3 of r, correct? So that is what they are, right? So they are 1/3 and 2/3 of r. So if you look into m to t, it should be mq and qt, right? So I could write m to t. Let me redo here. So m to t will be equals to m to q plus q to t, right? So plus q to t. Now m to q is half p, right? So this is equal to half of p, and q to t could be written as minus tq. tq is 1/3 of r, so it is half of p minus 1/3 of the vector r. So that is what this is. So this is half of p minus 1/3 of vector r. Correct? Now let's figure out what is O to t. So O to t is this length. It is combination of these two, right? So we can write down O to t is equal to OP plus P to t, right? So O to P is P and P to T is 2/3 of R. So we get our answer, which is equal to P plus 2/3 of R, correct? So that is how we are going to solve it. So it becomes very simple when you understand this particular ratio, right? So how do you write ratio in terms of the vectors? So that ratio, that means total is 3, right? So if I divide this into 3 equal parts, P2 is 2/3 and TQ is 1/3. So that helps to answer this, correct? Question 6b. RQ and OT are extended and meet at U. Find the position vector U in terms of P and R. Now that's the origin, right? So that will help us to get the position vector U. Now we are also given this is a rectangle, right? Which we worked in part A. And this is 1/3 of the whole thing. So this portion here is 1/3 of R, correct? So if you look into it, then we have two similar triangles. So let's take the big triangle, which is ORU. So this triangle is similar to that small triangle, which is TQU, right? So that means the ratio of sides are proportional. So we have a scale factor. So OR over TQ should be equal to the bigger length R to U over the smaller length QU, and that should be equal to this ratio, which is R over 1/3 of R, right? So basically we have the ratio is equal to 3, right? So that is 3. Now from this we can find OU, right? So we'll use this part of the equation to find U. So R to U could be written as RQ plus Q to U, and we are dividing by Q to U, and that is equal to 3. So that is R to Q is P, right? So we can write P dividing by Q to U, right? Plus Q to U divided by Q to U, which is 1, equals to 3. So we can take it to the right side. So we get the vector P over Q to U equals to 3 minus 1, since this is 1, right, which is 2. Okay, so from here you can get what q to u is, right? So you can get here cross multiply, so we get q to u is half of p. So this portion here is half p and this portion here is p, correct? So that's what we have. This distance is p and that is half of p. So total is how much? Total will be p plus half p, that is 3 over 2, right? So 3 over 2p is the total distance. Correct? So from O to U, this particular position vector, OU, should be equal to, the x value will be 3 by 2p and the y value will be r. Correct? So that becomes your position vector for U. Is that clear? So I hope that is how we will be doing it. Now let's do part C of this question. Question 6c. If mt is the vector 2k minus k and the magnitude of mt is square root of 180, find the positive value of k. So m to t is this particular vector which we are talking about, correct? We are given that its magnitude is 180 square root. So we are given that mt vector is basically equal to 2k minus k. So what is the magnitude of this vector? The magnitude of this vector is square root of 2k square plus minus k square, right? So which is 4k square plus k square, and that is equal to 5 square root 5, and k can be taken outside, right? And this magnitude is basically equal to square root of 180. So we need to find what k is. So from here, k is clearly equal to square root of 180 divided by 5, correct? So when you divide 180 by 5, you get 36, and we are looking for positive value of k, so that gives you 6. So our answer is k equals to 6. Perfect. So that is how we are going to answer it. So I hope that helps. Let's move on and take question number 7 now. Question number 7. Given f of x equals to 2x plus 1, g of x equals to x squared plus 4, h of x equals to 2 to the power of x, solve the equation f of x equals to g1. So f of x is 2x plus 1. Let's rewrite this. When I say g of 1, substitute 1 here, right? So when you write 1 here, you get 1 square plus 4. So that gives you 2x plus 1 equals to 1 square plus 4 is 5, or we have 2x equals to 5 minus 1, which is 4. So x is equal to 4 divided by 2, which is 2. Correct? So that is how we are going to solve. So the answer here is x equals to 2. Now let's do the next one. F inverse of x. Now one way to do the inverse is read in the backward direction, reverse operation, right? So inverse is the reverse operation. F inverse is, the function is times 2 plus 1. You actually first take away 1 and then you divide by 2 to get inverse. Simple as that. Find g of f of x in its simplest form. So g of f of x. So we'll write g of f of x is 2x plus 1. So let's write 2x plus 1. Now we'll substitute 2x plus 1 in the formula given for g of x. The function is x squared plus 4. So we'll have square of this, which is 2x plus 1 whole square, right? So that is x squared plus 4. So let's expand this. We get this as 2x, 2 square is 4, x squared, plus 2 times 2x, which is 4x, plus 1, plus 4, right? So that gives you 4x squared plus 4x plus 5. So that is the simplest form. So we'll write this as 4x squared plus 4x plus 5. D. Solve the equation h inverse of x is 0.5. So when we have h inverse of x as 0.5, you could write this as x is equals to h of 0.5, correct? So we can rearrange this equation and get direct answer. So when I say x is h of 0.5, we are given the function h of x is 2 to the power of x. So that should be 2 to the power of 0.5, which is half, right? 2 to the power of half, which is square root of 2. So here we get square root of 2 as our answer. Next one is write k if 1 over h of x is 2 to the power of kx. You have to find. So what is h of x? H of x is 2 to the power of x. So this implies that we can write this as, let's use a different thing, 1 over 2 to the power of x equals to 2 to the power of kx. Now, that means 2 to the power of minus x equals to 2 to the power of kx. Now, comparing the exponents when they have the same base, we can say k is equal to minus 1. So we get here k equals to minus 1. Correct? So that is how we will solve it. Now let's take question number 8. Question number 8. The grid shows the graph of y equals to cos x from 0 to 360 degrees. So let me just sketch it here. I'll make a rough sketch. So cos x is a function which is always between plus and minus 1, correct? And we need to sketch it from 0 degrees to 360 degrees. So it is kind of like this. Right? So these are the 4 quadrants, correct? 0, this is 90 degrees. That is 180 degrees, 270, and 360 degrees, right? So that is x and this is y. So y equals to cos x. Part A is solve the equation 3 cos x equals to 1. Give your answer correct to 1 decimal place. So when we have 3 cos x equals to 1, I could write cos x equal to 1 over 3, right? Now within this period, we can see that cos x equals to 1 over 3, we have 2 solutions. If we draw a line like this, then we get these 2 points as our solution, right? Quadrant 1 and in quadrant 4, cosine is positive, right? Let's try to understand. So we have cos as positive in these 2 quadrants. So these are the 2 answers which we are looking for. We'll first find this angle alpha here, and then that will be minus alpha, or we can say 360 minus alpha, correct? So what is x equals to, or this angle alpha equals to? X will be cos inverse of 1 over 3, right? So let's take a calculator and find the solution. So we have shift cos inverse of 1 divided by 3 equals to 70.5. 70.5 degrees. So that is one answer. The other answer has to be 360 minus 70.5, right? So 360 minus 70.5 is the other answer. So let's take away this value from 360. We'll do minus 360 and then take a positive value, 289.5. So that is 289.5 degrees, correct? So these are the 2 angles for which cos x will be 1 over 3. Perfect. So that is how you're going to get it, right? So we get x equals to 70.5 degrees or 289.5 degrees. Done. Part B is sketch the graph of sin x on the same grid. Well, for sin x, what do we have? It starts with 0 and it is 1 at 90, so that will be 1 for it. At 180, it is again 0. At 270, is minus 1. And at 360, it is going to be 0. So just connect these points and sketch your graph. And that is your sin x. Is that okay? So that is how you could do question number 8. Now let's move on and take question number 9. Question number 9. The diagram shows a trapezium ABCD. AB is parallel to DC. AB is 55, BD is 70, angle ABD is 40 degrees, and angle BCD is 32 degrees, right? We need to calculate A to D. Now to find A to D, we know in this triangle, two sides and an angle, right? So we know two sides and an angle. We can use cosine law, right? Since we know side, angle, side. Perfect. To find what AD is. So AD is basically equal to square root of 55 square plus 70 square minus 2 times 55 and 70 times cos of 40. Correct? Square root all this. So let's figure this out. So we'll do 55 square plus 70 square minus 2 times 55 times 70 times cos of the angle, which is 40. And this is 2026.45. We'll do square root of our answer and it gives me 45.0. So we'll write this as 45 meters. So this side is for us 45 meters. Clear? Second thing, we need to calculate the angle, the side length B to C. Now in this triangle, we know these two sides are parallel. Okay, how does that help? Now that forms a Z pattern, correct? So that means this angle of 40 is also equal to this angle as 40. So we have a combination here, side opposite to the angle, another angle is known to us, right? So that helps us to find what BC is using sine law. So in this case, we'll apply sine law. So let's find the answer. BC, we'll figure it out here itself. So what we get here is, let me do it here. So BC over sine of 40 degrees is equal to 70 over sine of the angle 32, right? So that gives you BC as equal to 70 times sine of 40 degrees over sine of 32 degrees. Let's calculate this out. So we'll multiply 70 by sine of 40 degrees and then divide by sine of 32 degrees. That is 84.9. So this gives you 84.9 meters. So we get this side as 84.9 meters. Perfect. Third thing, we need to calculate area of ABCD. Now ABCD is actually sum of two triangles, right? These are the two triangles. So we'll find the area as area of triangle ABD. Okay, so area of triangle, let me write here formula. Area of triangle ABD plus area of triangle DBC. Correct? Now, if you are given two sides and the included angle, then what is the formula? Then you can directly find the area as half of product of these two sides times the cosine of angle. So it is half of 70 times 50 and sine of angle, which is sine of 40 degrees. Plus, in this case, we need to figure out this particular angle. It should be 180 minus 40 minus 32, right? So let's find. So 180 minus 40 minus 32 gives us the angle of 108 degrees. Do you see that? So the area of the bigger triangle is half of product of these two sides, which is 84.9 times 70 times sine of the angle, which is 108 degrees. So let's calculate this. So it is, let me first do, okay, so 0.5 is half times 70 times 55 times sine of 40, right? So we get a number which is 1237, and then we'll add to this half of all this, right? So which is 0.5 times 84.9 times 70 times sine of 108, right? So that is 4063. So we get a value of 4063.43. Let me write down 4063.43. The units will be meters square, right? We could round this to, they have not mentioned, so we'll just round it to 4063 meters square, correct? So approximately that much. Okay. Now, the last thing which we need to find here is calculate the shortest distance from A to BD. Basically, this shortest distance, right? So this is what we need to find, perpendicular. Now, as you can see in this particular diagram, and that also gives you the idea how we got the area, right? So this is right angles. Now we have 40 degrees here, opposite hypotenuse is 55, and we need to find the opposite side. So we'll use sine. And that is why in the formula we have this sine 40. Do you get the idea, right? So we can again work on the same thing, and we now know that sine of 40 degrees, let's write down, sine of 40 degrees is actually equal to the perpendicular. Let's call this point as P, AP over the hypotenuse of 55. So that gives you AP as 55 times sine of 40 degrees, correct? So which is 55 times sine of 40 degrees, 35.35. So you can approximate this to 35 meters, correct? So that is how we get this shortest distance. Now actually speaking, when you are doing this formula, right, so you could see this. This is your height. You see that? This is the height and that is your base. So that is the derivation of area. That is how we derive. So we actually find this height using this concept. Perfect. This is your question number 10. We'll actually have rewritten this question. We'll work on what I have copied. So what we have here is part A is show that the volume of a metal sphere of radius 15 centimeter is 14140 centimeter cube, correct to 4 significant figures, right? Now we are given the radius, which is 15 centimeters. You're also given the formula for volume of a sphere, which is 4 by 3 pi r cube. So we know volume is 4 by 3 pi r cube. This is the formula. So we'll just substitute 15 here and calculate the value. So we have got 4 by 3 pi, r is 15 for us, 15 cube, and we'll just find this answer, right? So 4 times pi, so it's just 4 times shift and then you get pi, and then times 15 cube, and then we are going to divide this by 3 to get our answer, which is in decimals 14137. 14137.16. Now when we say we have to round it to 4 significant places, then that 37 becomes 40. So this is equal to 14140 centimeter cube. Perfect. So that is how you do part A. Now part B is the sphere is placed inside an empty cylinder tank of radius 25 centimeters and height 60 centimeters. Tank is filled with water. Now, so the idea here is that, as shown here, that cylinder has been placed now in the tank, and then the tank is filled with water. Perfect. The question is, calculate the volume of water needed to fill the tank. So, since that much will actually, for our calculations, we'll use this number, right? Because that is the actual number. So what we will do here is, for our cylinder, which is given to us as, we have now placed the sphere inside it. Of course it will land right there in the center. So what I'm trying to do is kind of like this, okay? So now the sphere is placed inside an empty tank of radius 25. So this radius is 25 and height is 60. So the volume will be volume of the tank, which is pi r square h. So basically, we will calculate the volume of the tank, which is pi r square h, and from that we are going to minus the volume of the sphere, which is 14137. Is that okay? That is what we will go. So that is the volume of water which will be in the tank. So in our case, we can write 3.14, and radius is 25, 625 that is, square. Height is 60, and then we'll take away 14137. Is it okay? So let's use this. So we have 3.14 times 25 square times 60, and from this, which is 117750, we'll take away 14137 minus 14137, which is equal to 103613, correct? So that becomes the answer for us, right? Now in this particular case, when we are rounding our numbers to 4 significant places, I would like to write this answer as 1040. So we'll make it 4, right? So 4000. Do you understand? So we round our answer to 4 decimal places, 4 significant places. So I'm rounding to 4 significant figures and then writing our answers 104,000. Perfect. And the units will be the units of the centimeter cube, right? That much is the volume. Second is, the sphere is removed from the tank, calculate the depth of water in the tank. Now if you remove the cylinder, the water level will come down, right? So once you have filled it up, after removing this outside, the water level will come down, correct? And the level by which it comes down is the same as the volume of sphere, correct? So basically what is happening here, if the height, or let's say this down is d, for example, in that case this volume should be equal to volume of the sphere. So again we'll use the same original figure, which is 14137.16. that is the volume removed. So volume decreased shown here will be pi r square h, which means pi, radius is 25 square, and the depth d is d, right? Pi r square h. Now from here we can find what d is. So 14137.16 divided by pi, let's take as 3.14 times 25 square. That is the answer, correct? So we'll again use 14137.16 divided by 3.14, and then we'll divide by 25 square. So that gives you the answer as equal to 7.2, right? 7.2 centimeters. So it says, the sphere is removed from the tank, calculate the depth d of the water in the tank. Oh, this is the decrease. So the whole height is how much? 60, right? So from 60, it will come down by this thing. So the height h will be equal to, so height h will be 60 minus 7.2, right? Okay. So we'll do 60 minus 7.2 as equal to, in decimals, 52.8. Or you can round this to 53 centimeters, correct? You understand? So alternate method could have been that we know the difference in height, which is that much. This is the volume, right? We can equate this volume to pi r square h and get the height directly also, right? We could do that. So that is alternate method. Let's write down. Alternate will be, we calculated the volume of water, which was 103613, right? So that is the volume. So which is 103613, that is the volume, which should be equal to pi times radius square times height. And then when you divide both sides by pi times 25 square, right? So pi times 25 square, you get height, right? So height will be that much. So let's recalculate, get that answer also. 103,613 divided by, let's say 3.14, and then we'll divide this by 25 square. And that gives you 52.8. 52.79, which could be rounded to 53 centimeters, right? So any method you could adopt. Perfect. So you get the same answer, which is 53 centimeters approximately. Correct. So now we'll do 10C, which is relating the cone and the sphere, right? So the question here is, given a solid circular cone and a solid sphere, right? So we are given a solid circular cone. I'll just sketch it here. And a solid sphere. The cone has a radius of 5x. So this is 5x. And a height of 12x. And this height is 12x. The sphere has radius of r. This radius is r. The cone has the same total surface area as the sphere. So both their areas are same. Perfect. Okay. Show that r square equals to 45 over 2 x square. Right. We are also given the formulas. So the curved surface area of a cone is pi r l. Since it is solid, we'll take the circle also. Right. So what we are given here is, when we say that the sphere has radius of this, and we are also given that cone has the same total surface area as that of sphere. Now the surface area of sphere is 4 pi r square, and that of the cone is pi r l. L is the lateral length, this L. So we need to first find what L is, right? So L will be equal to, using Pythagorean theorem, square root of 12x whole square plus 5x whole square, right? So that is what it is. So we'll take x outside, right? X is common, and square root of 12 square. So within square root, we can do 12 square plus 5 square, and that gives you 13. So we got x times 13 as the lateral length. Okay. Now what is the surface area of this particular cone? Now surface area of the cone will be pi r square, which is the solid surface at the bottom, plus pi r l, which is pi times r times l, where l is 13x. Perfect. Now we are given this is same as the surface area of a sphere, which is 4 pi r square. So we can now equate the two. So we have 4 pi r square, that is the surface area of a sphere, should be equal to pi, the radius is given to us as 5x. So we'll replace this r with 5x. So we have got pi times 5x whole square plus pi times radius is 5x and lateral side is 13x. Correct? So that's what we get. Now, so from here we can have 4 pi r square equals 2. Now multiplying, we get x square as a common factor. Pi is also common factor. So we have pi x square, and within this bracket we have 5 square, which is 25, plus 13 times 5. 5 times 3, 15, and 1, 65. Correct? So that's what we have. And you can now isolate r square, right? That cancels. Correct? So now you can isolate r square. So what we have here is 4r square is equal to x square times, add them up. So 5 and 5, 10, and this gives you 90, right? 90x square. So r square is 90x square divided by 4, and that gives you that r square is 45 over 2 x square. Is that clear? So that is how we are going to show it. So in this statement here, we said that surface area of sphere is equals to area of cone, right? And area of cone is combination of two, lateral and the base. So that's how you prove it. Okay, so it's time to take the last question. Question number 11 now. Question number 11. A curve has equation y equals to x cubed minus 6x squared plus 16. Find the coordinates of the two turning points, right? So we have two turning points here. B is determine whether each of the turning point is a maximum or a minimum. Give reasons, right? So that is what we need to do. Now in this particular case, since it is a cubic equation, right? So definitely we know the behavior. So it's a cubic function. So in a cubic function, leading coefficient is positive. Since we have two zeros, we know that the graph should be like what? The graph should be kind of like this. Since the leading coefficient is positive, right? So definitely from here, the first turning point will lead to maximum. So this is your maximum. And the second turning point will lead to minimum, right? That is from our knowledge of functions. Now, the second question here is, how do we find the turning point? Now at the turning point, let's say turning points, rate of change is 0. What I'm trying to say here is that if you draw a tangent, it will be horizontal at these points, right? Rate of change is 0. So you can find rate of change of this equation and equate it to 0. So we can normally find taking a derivative. So the derivative for this function will be 3x squared minus 12x, right? Now, to make it 0, we'll factor this 3x, and we have here x minus 4. So the 2 points at which it is 0 will be what? One, x could be equal to 0. The other one, x could be equal to 4, right? So these are the 2 points where we could have a 0, right? So I hope you understand the derivative. We have applied the power rule to find the derivative. If you have x to the power of n, let's say y equals to x to the power of n, then dy dx, the derivative, is n times x to the power of n minus 1. So that is the rule which we applied. So since it is x cubed, 3x squared is the term you get. Since it is minus 6x squared, 2 gets multiplied with 6, you get 12x, so that is 12x. Equating that to 0, we took 3x common, left with x here, and 12 divided by 3 is 4. So we get these two answers, right? So this point is for x equals to 0, and this point is when x is equal to 4. Perfect. Now, to get the y value, let's substitute the values here. So if I write, let's calculate these values here now, right? So if I write 0, that is f of 0, will give me 0 minus 0 plus 16. So the first point here, the y value will be 16. For the second point, which is f of 4, we'll substitute 4 here. We get 4 cubed minus 6 times 4 squared plus 16. Let's calculate this. So we have 4 cubed minus 6 times 4 squared plus 16, and that is equal to minus 16 for us, right? So this point here, at x equals to 4, we get y equals to minus 16, which is the minimum, right? Therefore, we have a maximum at the first turning point, which is at 0, 16, and we have minimum at the second turning point, which is 4 minus 16. Do you see that part? So that is how we could show. So Find the coordinates. First answer will be the coordinates for us are 0 and 16. And the second one is at 4 and minus 16. These are the two coordinates. And how did we find whether they are maximum or minimum? By calculating the value, you can see this, right? That is one thing. Second, we can analyze this derivative on either side. So that is the next part which you could do, analyzing it on either side. We have shown it with the help of a graph. So our reasoning is from the graph. Since leading coefficient is positive, the curve moves from negative to positive, quadrant 3 to quadrant 1. With these two turnings, that is the only way it could do, right? And therefore, there has to be a maximum at the first turning point and a minimum at the second turning point. So we're actually not going for reasoning out analysis of this rate of change. Of course, you could do it, that the rate of change is increasing and then decreasing. And in this case, it is decreasing and then increasing to reason out. But that's all up to you. As far as I'm concerned, this should also work, right? Now, when there is scarcity of time, these kinds of reasonings are good enough, right? So that's what I think. So I hope you find the solutions interesting and useful. We have used different kinds of techniques while solving this particular test paper. One of them was to look into a function which was odd function. So we could actually sketch the function with half the points, and we could answer most of the questions because we identified the function as odd function. Now here also, understanding the behavior of the curve or the polynomial helps us to very efficiently answer this particular question. Now we also learn a new technique of finding the points after rotation of 90 degrees clockwise. So I hope that all helps. Feel free to post your questions, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.